Hello everyone, welcome to my global classroom mathematics revelation. Today we are looking at trigonometric function, and we are going to be looking at the basic trigonometry ratio that is dealing with right angle triangle. Right angle triangle. This is a right angle triangle. Here we have this angle here is 90 degrees. So this is theta, this angle theta. Yeah, and since we have theta to be in this position, this automatically is the adjacent. It's ABC, triangle ABC. This is your hypotenuse, the line that faces the right angle. Then you have the opposite, the line that faces the given angle theta. And you have your adjacent, which is the line that both theta and right angle rest on. And based on the definition of trigonometry, your cos theta is equals to adjacent over what? Hypotenuse. And that will be equals to C over A from the diagram. Is C over A. Then we have sine theta is equals to opposite over hypotenuse. This is opposite. Opposite is equals to B. B is equals to opposite. And we have opposite over hypotenuse, which is B over C. Then we have tan theta. Tan theta is opposite over adjacent, which is the same thing as B over C. That is opposite over what? Adjacent. Then we have other ratios such as your sec theta has sec theta. Sec theta is 1 over cos theta. Your cot theta is 1 over tan theta and is equals to sin theta over cos theta. Then you have cosec theta is equals to 1 over sin theta. So these are the basic trig ratio. We are going to take some examples on this. Take some examples on this. Now let's look at this. Example 1. Given that sin theta is equals to 8 over 10 and theta is an acute angle. Acute angle means theta lie between 0 and 90 degrees. Lie between 0 and 90 degrees. So we are asked to find the value of cos theta, tan theta, sec theta, cosec theta, and cot theta. So first of all, let's draw our right angle triangle. Solution. Let's draw a right angle triangle. This is a right angle triangle. This is the angle theta. So if theta is here, sine theta is given as 8 over 10. Remember that sine is opposite over hypotenuse. So this is your right angle. The line facing the right angle is what? Hypotenuse. This is 10. And this will be the opposite because this is the line that faces the angle theta. So now to be able to get the adjacent, you use what we call Pythagoras Theorem. Pythagoras Theorem, if this is A, B, C. So we are looking for what? AB. From Pythagoras Theorem, we have AB squared must be equals to 10 squared minus 8 squared. This will be equals to 100 minus 64. So our AB is the square root of 36, which is equals to 6. So AB is equals to 6. So this part is 6 centimeter. Here is 10 centimeter. Here is 8 centimeter. Now, we are to determine the value of cos theta. How do we know the adjacent? 6 centimeter. We know that cos theta cos theta, we said cos theta is adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent here is 6 over 10. If I divide through, that will give me 3 over 5. 3 over 5. Then I have the next one is tan theta. Tan theta. This is 1, this is 2. Tan theta. Tan theta, we define tan theta as opposite over adjacent. We say it's opposite over adjacent. That's the definition of tan theta. So, opposite over adjacent, that would be equals to 8 over 6. This will be equals to 8 over 6. This is opposite is adjacent, and that will be equals to 4 over 3. 4 over 3. Then we also have sec theta. Sec theta, that is 3. Sec theta, we said that is 1 over cos theta. We have the value for cos theta to be equals to, value for cos theta is equals to 3 over 5. So we have 1 over 3 divided by 5. And if you solve this, that would be equals to 5 over 3. Then 4. For we have cosec theta. Cosec theta. Cosec theta is defined as 1 over sin theta. Cosec theta is equals to 1 over sin theta. We have the value of sin theta to be equals to 8 over 10. So we have, this is the same thing as 1 divided by 8 over 10, and that is 10 over 8, which is 5 over 4. Why is it 5 over 4? 2 here is 5, and 2 here is what? Is 4. Then lastly, we have cot theta. Cot theta. Cot theta, we say cot theta is the same thing as sin theta over cos theta. So it's the same thing as sin theta over cos theta, and that would be the same thing as 6 over 10 divided by 8 over 10. 6 over 10, 6 over 10 divided by 8 over 10. We have the values already. And if you divide that, this will be the same thing as 3 over 4. The same thing as 3 over 4. Don't remember, you are going to invert here. Let me invert it. Let me quickly invert it. If I invert this, I'll have a 6 over 10 times 8 over 10. 6 over 10 times 8 over times 10 over 8. So 10 will cancel out 10. So that will give me 3 over 4 as the final answer. So look at it again. Look at it again and copy it. Now we are going to be looking at the ratio of complementary angle. What are complementary angle? Two angles added together to give you 90 degrees is called complementary angle. If two angles are added together to give you 90 degrees, it's called complementary angle. If two angles are added together to give you 180 180 is called supplementary angle. So now we are going to be considering ratio of complementary angle. Now let's consider this diagram here. Here is theta, here is alpha, here is 90 degrees. We know that the sum of angle in a triangle is 180. And if the sum of angle in a triangle is equals to 180, then this implies that alpha plus theta plus 90 is equals to 180. And alpha plus theta will be equals to 90. Because if you bring 90 to the other side, this other side, you have 180 minus 90 will give you what? 90 degrees. Which implies that your alpha is equals to 90 minus theta. That's what we have here. Say alpha is 90 minus theta, and theta is also 90 minus what? Minus alpha. Theta is also 90 minus alpha. Now we have our cos theta. Cos theta is the same thing as sine alpha. Cos theta is the same thing as sine alpha. And we can say this is the same thing as what? Sine 90 minus what? Theta. Because 90 minus theta will give us alpha. 90 minus theta will give us alpha. So, we also have sine theta is equals to cos alpha, and it's the same thing as what? Cos 90 minus theta as cos 90 minus theta. So sin theta is equals to cos alpha. Then we also have our tan theta. Tan theta is the same thing as cot alpha. Same thing as cot alpha, and it's the same thing as cot 90 minus theta. So this is the ratio of complementary angle. Now you can check with your 4-figure table or your calculator. You will observe that your cos 30 degrees, if you check, you will observe that your cos 30 degrees is the same thing as sine 60 degrees. Because 90 minus 30 is going to give you what? 60 degrees. It's going to give you 60 degrees. So your cos 50 will also give you cos 50. You can check this with your 4-figure table or calculator. Will give you sine what? 40 degrees. 40 degrees. Now that will take us to ratio of general angles. Ratio of general angles. Now let's continue with ratio of general angle. Now we have a 4 quadrant between 0 degree and 360 degree. We have 4 quadrants. This is the first quadrant, this second quadrant, this third quadrant, and this fourth quadrant. Now, in the first quadrant, this is the first quadrant. The angle lies between. That's theta 1. This is the first quadrant. The angle must be what? 0 is less than theta. Theta is less than 90 degrees. This is the first quadrant. Yeah, all trigonometric ratios are positive. All trig ratios are positive. So you have sine theta is equals to plus sine theta. You have cos theta is equals to plus cos theta. Then tan theta is plus tan theta. So that's for the first quadrant. Then we have the second quadrant. The second quadrant, the angle lies between. Angle in the second quadrant line between here is between here you have your 180 between here, so you have the angle in this direction. So you have this angle theta 2. Let's take it as theta 2. Theta 2. So you have this angle is 90 is less than theta, then theta is less than 180. So the angle lies between 180, between 90 degree and 180. So here we have only sine. Any angle that is here, only sine is positive. So you have sine theta. Sine theta is equals to 1 sine 180 sine 180 minus theta, and it's the same thing as plus sine theta. So anything you have here, subtract from 180 and the result will also be positive. Subtract it from 180. Then you have your cos theta. Cos theta is minus cos 180 minus theta, and that will be the same thing as your minus cos theta. So whatever you get, you take the negative value of it. Whatever you get, take the negative value of it. Then we have tan theta. Tan theta is minus tan 180 minus theta. And so in the second quadrant, that's tan theta. Now, in the second quadrant, only sine is positive, cosine and tan is what? Negative. Take note of that in the second quadrant. Now let's look at the third quadrant. The third quadrant. Yeah, third quadrant. Your 180 is less than theta. Theta is less than 270. So the angle rate between 180 and what? 270 for the third quadrant. And here, your sine theta is negative. So you have sine theta is minus sine theta minus 180. Theta minus 180. So any value you have is above 180. Just subtract 180 from it. It will give you the value, the acute value. It will give you the acute value. So here we have minus sine theta. Minus sine theta. Cos theta is also negative here. That is cos theta minus 180. And this is equals to minus cos theta. So it's going to give you a negative value. Cosine is negative in the third quadrant. But the tan is positive. Tan theta is equals to minus tan theta minus tan theta minus 180. Plus is equals to plus tan theta. So in the third quadrant, only tan is positive, while sine and cosine is what? Is negative. While sine and cosine is negative. Now let's quickly look at the fourth quadrant. The fourth quadrant. First quadrant. Now the fourth quadrant lies between 270 and 360. That's the fourth quadrant. So our fourth quadrant. First quadrant is here. It's the first quadrant. So let me label it as theta 4 to show that it's in the fourth quadrant. Here you have sine theta is equals to minus sine 360 minus theta. So whatever you have, because once it's greater than 270, subtract from 360 to get the acute angle value. This one will be equals to minus sine theta. Minus sine theta. Also we have cos theta here is plus. Cos theta is plus in the fourth quadrant. That is 360 minus theta. And that will be equals to plus cos theta. Then finally we have tan theta. Tan theta here is equals to minus, that is minus tan 360 minus theta, and that will give us minus tan theta. So what we do here is to solve using the acute value, the acute angle value. We said that in the first quadrant they are all positive because angles in the first quadrant they are acute. But when we move into the second quadrant, we subtract from 180 to get the acute value. Subtract. Then in the third quadrant, we subtract 180 from any value that's given to us because it's already above 80 to be able to get the acute value. But it's important you take note that in each of the quadrants, in the first quadrant, all the trigonometric ratios are positive. While in the second, you have just sine positive. In the third, you have tan positive. And in the fourth, you have what? Cosine positive. Now let's look at ratios of 30 degree and 60 degree. These are special angles. So special angles, the other form of special angle is 90 degree and 45 degree. But now we are just going to look at 30 degree, 60 degree, and 45 degree. Now let's consider a triangle, an equilateral triangle. This is an equilateral triangle. This side is equals to this side. this side is equal to this side, and the three sides are equal, then we have this line is also equal to this line. If I draw a perpendicular line, if here is 1, here will be 1 centimeter, here is 1 centimeter, then here must be 2 centimeter, here must be 2 centimeter. Now if I draw this perpendicular line, I will obtain a right angle. Remember that anytime we make use of the word perpendicular, it always forms a right angle. Now look at this. If I want to find the value of this line, let this one be AB, CD. If I want to determine the value of BD, then I have BD square. BD square will be equals to 2 square minus 1 square. This is 1 centimeter. And that's the same thing as 4 minus 1, which is equals to 3. So this line BD will be the square root of 3. So let's put it here. Here's the square root of 3. Remember, an equilateral triangle has all the angles equal. Here is 60 degree, here is 60 degree. Here is 60, here is 60. And since we divide this angle into 2, here will be 30 degree, and here will be 30 degree. Now, sine, let's start with sine 60. Sine 60 degree, we've already said that what? Sine is what? Opposite over what? Adjacent. Opposite over hypotenuse, over hypotenuse. So, this will be the same thing as, this is 60 degree, this is opposite, this is hypotenuse. That will be equals to root 3 over 2. Cos 60 degree, cos 60, we define cos as adjacent over hypotenuse. We define cos as adjacent over what? Hypotenuse. Adjacent over hypotenuse. So I have my cos. My cos 60 is adjacent over hypotenuse. That will be equals to, this is adjacent, this is hypotenuse, that will be 1 over 2. 1 over 2, that is half, or what you call 0.5. Now we have tan 60. Tan from our previous definition is what? Opposite over adjacent. Opposite over adjacent. So let's see. Opposite over adjacent, that is root 3. That will be root 3. Now let's look at the ratio of 30 degree. The ratio of 30 degree. Sine 30. Sine 30 degree. Now, if theta move here, the angle move here become the adjacent. This become the adjacent, while here become what? The opposite. So sine 30 is what? Opposite over hypotenuse. Opposite over hypotenuse. That will be 1 over what? 2. 1 over 2. So you see that your sine 30 is the same thing as cos 60. From when we talk about, I think when we discuss ratio of complementary angle, we discuss something like this under ratio of complementary angle. Then we have our cos theta. Cos theta is adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent over hypotenuse. The adjacent here is root 3 over hypotenuse, which is what? Root 3 over what? Over 2. So you see, cos 30 degree is the same thing as sine 60 degree. So that 30 plus 60, that will give you what? 90 degree, which are what? Complementary what? Angle. Then lastly, we have your tan 30 degree. Tan is what? Opposite over what? Over adjacent. Opposite over adjacent. Opposite over adjacent. This is opposite, this adjacent, which is 1 over root 3, and that will be root 3 over 3. So this is the ratio of angle 30 degree and what? 60 degree. Quickly we move into the ratio of angle 45 degree. Angle 45 degree. Now this is ratio of 45 degree. This triangle ABC. ABC. This triangle ABC. Now if here is 45, here is 45, this line will be equal to this line. So here is 1 centimeter, here 1 centimeter. By Pythagoras Theorem, 1 square plus 1 square, that gives you root 2. So to get the value of BC square, that will be equal to 1 square plus 1 square, and that will be 1 plus 1, which is 2. So BC will be equal to the square root of what? 2. That is how we get square root of 2 here. Now sine 45 is sine is opposite over what? Hypotenuse is your opposite. Yes, 1 over root 2, which is root 2 over 2. If you rationalize, we have done sort, so you can go back to sort to know how we get this. Then we have cos theta, as cos 45 now. It's the same thing. Cos 45 is the same thing as sin 45, because adjacent is equal to what? Opposite. So you have 1 over root 2, and that will be equal to root 2 over 2. Then finally here, you look at tan 45. Tan 45 is opposite over what? Adjacent, and that will be equal to 1. That's 1 over 1, which is 1. 1 over 1, which is 1. So quickly write it down while we take some questions to illustrate what we have been saying. Write the value of each of the following in short form. We have tan 300, sin 240, cos 315, cos 135, and tan 150. Solution. Solution. The first one is tan. A is tan 300. Tan 300 degree. 300 is in the fourth quadrant, and in the fourth quadrant we subtract from 360. So here, remember, tan is negative. That will be tan 360 minus 300. Tan 360 minus 300, that will be equal to minus tan 60 degree. If you check the ratio of your angle, tan 60 degree, tan 60 is root 3. Tan 60 is root 3. Tan 60 is root 3. So this will be equal to minus root 3. Minus root 3. Then P, we have sine 240. 240 is the third quadrant. Sine is negative. That's minus sine 240. Remember, in the third quadrant we subtract 180 from theta. This will be the same thing as minus sine 240 minus 180 is 60 degree. And sine 60 degree in short form is root 3 over 2. That will be minus root 3 over 2. Minus root 3 over 2. Then the next C. C, we have cos 315. Cos 315. Cos 315 is in the fourth quadrant, and cos is positive, so it's cos plus cos. And in the fourth quadrant, we subtract from 360, 315. And this is the same thing as cos 45. What is cos 45? Cos 45 is root 2 over 2. This is equals to root 2 over 2. Root 2 over 2. Now let's look at D. Number D, we have cos 135. Cos 135. Yeah, is second quadrant. 135 is below. It's below 180, but it's greater than 90 degrees. So we are subtracting. Cos is negative here. That is minus cos 180 minus 135. 180 minus 135 is 45. So that will be equals to minus cos 45. And it's the same thing as what? Root 2 over 2. Root 2 over 2. Then we have lastly tan 150. Tan 150, this is E. Tan 150, tan is negative in the second quadrant. 150 is the second quadrant. That will be minus tan, bracket, 180 minus 150. And that will be equals to minus tan 30 degree. So tan 30 degree is the same thing as minus root 3 over what? Over 3. This is minus root 3 over 3. Minus root 3 over 3. Now we are going to be looking at trigonometric identity. Trigonometric identity. Now we have a triangle with an angle theta. This is y, the vertical part of the triangle, and this is x, the horizontal part of the triangle. This triangle is a right angle triangle. So we have triangle, here is AOB is a right angle triangle. It's a right angle triangle. Then we have our, here is 1. We have our O, line OA is 1. Your OB is equals to X, and your AB is equals to Y. So using Pythagoras theory, we have that your AB squared plus OB squared must be equals to OA squared, which means that y squared plus s squared must be equals to 1 square. Must be equals to 1 square. Now, if we take y to be equals to sine theta, if y is equals to sine theta and s is equals to cos theta, that implies that sine theta squared plus cos squared theta is equals to 1. So this is our first trigonometry identity. Sine squared theta plus cos squared theta is equals to 1. That is our first equation. Now, from the first equation, if I divide through by cos theta, divide through by cos squared theta, so I'm going to have sine squared theta over cos squared theta plus cos squared theta over cos squared theta, and that will be equals to 1 over cos squared theta. But recall that sine theta over cos theta is equals to tan theta. Is equals to tan theta. So here will give me tan squared theta plus cos squared theta over cos squared theta is 1. And 1 over cos squared theta, from our previous study, that will give you your sec squared theta. Sec squared theta. So this is going to be our second word identity. This is going to be our second identity. Now remember, we have sine squared theta plus cos squared theta is equals to 1. And we have divided through using cos squared theta. Now what if I divide through by sine squared theta? If I divide through by sine squared theta, I'm going to have sine squared theta over sine squared theta plus cos squared theta over sine squared theta. This is theta, and that will be equals to 1 over sine squared theta. Now this will give us sine squared theta plus over sine, this is 1 plus cos squared theta over sine squared theta is cot squared theta from our previous study, cos squared theta. And this will be equals to, and 1 over sine squared theta is cosec squared theta. And this will form the third identity. Now, just to refresh your memory, I want you to take note of this. To refresh your memory, Remember that cosec theta is 1 over sin theta, sec theta is 1 over cos theta, cot theta is 1 over tan theta, which is the same thing as cos theta over sin theta, because tan theta is sin theta over cos theta. So if you take the reciprocal of tan theta, it's going to give you what? This value. So I want you to write this down while we take some time to prove some identity. I will take some time to prove some identity. Prove that sin theta over 1 minus cot theta plus cos theta over 1 minus tan theta is equals to cos theta plus sin theta. Solution. Now what I will do, I will solve this and solve this, then combine them together. So let me start from this side. I know that sin theta over 1 minus cot theta is the same thing as sin theta over 1 minus cot theta is the same thing as cos theta over sin theta. And if you solve this, you have sin theta over the LCM here will become sin theta. Sin theta. The LCM of 1, remember this will be over 1. Don't forget that. So 1 divided sin theta will give you what? Sin theta. Sin theta minus sin theta divided sin theta will give you cos. Will give you sin theta times this will give you minus cos theta. So you now have sin theta times, using division, times sin theta over times sin theta over sin theta minus cos theta. So our final answer here will be equals to sin squared theta over sin theta minus cos theta. So that's for the first part. We'll get this answer for the first part. I'll solve for the second part so that we can bring the two together. Now the second part is cos theta over 1 minus tan theta. This is cos theta over 1 minus sin theta over cos theta. If you find the LCM, you have your cos theta over 1. Find the LCM. The LCM is cos theta. So 1 divided will give you cos theta minus sin theta. And if you invert, like just what we did in this case, you will have cos squared theta over cos theta minus sin theta. So if we rearrange our equation, we arrange the equation, we are going to have now we have our sin theta over 1 minus cos theta plus cos theta over 1 minus tan theta. It's the same thing as sin squared theta over sin theta minus cos theta plus cos squared theta over cos theta minus sin theta. So we solve this now. We solve this other part. We have sin squared theta over sin theta minus cos theta plus cos cos squared theta over cos theta minus sin theta. If I find the LCM, the LCM is going to be sin theta minus cos theta bracket cos theta minus sin theta. So if this one divides, you'll be left with this. So this will give me sin squared theta bracket cos squared theta minus minus cos theta into bracket cos theta minus sin theta plus, if this one divide, you'll be left with what? With this cos squared theta into bracket cos theta minus sin theta. So if we simplify this, we quickly simplify this. Later, introduce a negative to this side, so that here we give you sin theta, so that, yes, introduce a negative, I'm sorry, hold on. So now, what I'm trying to do here is to introduce a negative here. If I introduce a negative, sin will become plus, and cos will become negative, so that these two can be the same. So this will give me minus sin squared theta, minus times this will give you sin theta minus cos theta. I hope I'm very clear with this. I introduce a negative to this part. So here become plus, here become minus. Plus cos squared theta bracket sin squared theta, sin theta minus cos theta. Everything is over, divided by sin theta minus cos theta bracket cos theta minus sin theta. So what we have here, these two is the same. If you factorize, become the same. So you have cos squared theta minus sin squared theta. You factorize, bracket sin theta minus cos theta. Everything is over. Sin theta minus cos theta, bracket close, bracket cos theta minus sin theta. So these two, this can cancel this. This can cancel this. So if I expand this will give me, yes, difference of 2 square. I can see difference of 2 square there. So I'm going to expand this one at the top to give me cos theta minus sin theta, bracket close, bracket cos theta plus sin theta. Everything is over. We have cos theta minus sin theta. So this can cancel this. And our final answer will be cos theta plus what? Sin theta. And that is what we are asked to prove. So just look at it, write it down. Look at it clearly. Write it down. It's self-explanatory. Write it down.